Yes. Hello students. Welcome back to the class. Last class we discussed about question number 17 A and B both. Now coming to the question number 18. Question number 18 in the next module start ಆಗುತ್ತೆ, that is module number 5. And the questions are given in a random way. ಅಂದರೆ ಇದು ತುಂಬಾ ರ್ಯಾಂಡಮ್ ಆಗಿದೆ ಕ್ವಶನ್ಸ್, ಕಂಟಿನ್ಯೂಟಿ ಇಲ್ಲ ಅಲ್ಲಿ. ಸೊ ಅದರಿಂದ ಸ್ವಲ್ಪ ಇಂಟ್ರೊಡಕ್ಷನ್, ಆಫ್ಟರ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಅಸೈನ್ಮೆಂಟ್ ಕ್ವಶನ್ಸ್. ಓಕೆ, ನೌ ಕಮಿಂಗ್ ಟು ದ ಮಾಡ್ಯೂಲ್ 5. ದ ಮಾಡ್ಯೂಲ್ 5 is like this. The module contains 3 chapters. ಇದರಲ್ಲಿ 3 ಚಾಪ್ಟರ್ಸ್ ಬರುತ್ತೆ. ದಟ್ ಈಸ್ electrical conductivity, the property of the electrical conductivity. It is discussed in 3 cases. So that is electrical conductivity in metals, electrical conductivity in semiconductors, and electrical conductivity in insulators. Insulators is nothing but dielectrics. So 3 chapters now separate ಮಾಡಿದ್ದಾರೆ. So each chapters we have to discuss here. First we will go for the electrical conductivity in metals. So in electrical conductivity of metals, again we are dividing here into 2 categories. One is classical theory and other is quantum theory. You know that classical theory is a old mechanics and it is failed to explain so many concepts. Then after that only this quantum theory arrived. Okay, so first classical theory, that model, we should discuss about the model, that is what their assumptions and what they have faced the failures, those and all we have to discuss. Other assumptions, failures ಎಲ್ಲ discuss ಆದ್ಮೇಲೆ then we will go for the quantum mechanics. So in this quantum theory we have to find out the model. So what kind of model they have given and what are their assumptions. Then finally we will go for the success of the quantum theory. Okay. See here why I put into marks here and write marks here means, so this classical theory it is not there for your syllabus. Andre nimma previous syllabus ge idu ittu, but right now for your 18 syllabus this classical theory is not there, only quantum theory is there. That's why I put into mark for this, means the syllabus is not required for this your syllabus. This classical theory, only quantum theory you have to concentrate. But without understanding the classical theory ನೀವು ತಿಳ್ಕೊಳ್ದರೆ this quantum theory understanding is not possible. It is too difficult, ಸ್ವಲ್ಪ difficult ಅನ್ಸುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ here in this class I am discussing classical theory. Okay, now first go for the classical theory. So classical theory is a model. ಅವರು ಈ electrical conductivity of metals ನ explain ಮಾಡೋದಕ್ಕೆ try ಮಾಡಿದ್ರು. That concept is explained through some kind of model, and they have assumed the model called the kinetic theory of gas models. Means they are considering the electrons as a gas molecules, how the gas molecules are behaving in the same way electrons also behave, like that they assumed. Now first to go for the assumptions of the classical theory. ಅವರು ಏನೇನು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡ್ರು ಈ ಕಂಡಕ್ಟಿವಿಟಿನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದಕ್ಕೆ. Okay, first go for the first assumption. In metals, outermost electrons are responsible for the conduction, which are also called as valence electrons. Means here only the outermost electrons, means free electrons, or valence electrons. Valence electrons only responsible for the conduction. So outermost electrons ಮಾತ್ರ ಕಂಡಕ್ಟಿವಿಟಿಗೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ ಅಂತ ಅವರು ಫಸ್ಟ್ ಅಸಂಪ್ಷನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Now go for the second assumption. The electrons in the metal are considered equivalent to gas molecules. So I told you already kinetic theory of gas model ಮೇಲೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಇದನ್ನ. So they are considering each electron as a gas molecule. How the gas molecule will move? If you are imagining on the chamber, within the chamber if you fill the gas, how the gas molecules will move? They will collide with the walls of the container, they will change the direction randomly, like that. In the same way electrons also moving inside the metals ಅಂತ ಅವರು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರು. So electrons in a metal are considered to be equivalent to gas molecules, and they should obey the gas laws. That is kinetic theory of gas laws. They should obey. So according to them, the kinetic energy of that moving electron should be equal to this much. So you know that kinetic theory, that is the kinetic energy, it is half mv square, where v is the velocity of the gas molecule. Okay, and 3 by 2 kT. This is from the kinetic theory of gases. So each gas molecule contains the kinetic energy this much, where K represents the Boltzmann constant and T is the temperature. Okay, so kinetic energy is equal to 3 by 2 kT. Now coming to the third assumption, that is the effect of electric potential due to positive ion cores on the electron is considered to be constant and hence neglected. Illi you should consider about the electron and the nucleus distance. So you know the atomic model, and nucleus will be at the center and electron will be revolving around the nucleus. Means nucleus matte electron madhye certain amount of distance will be there. That is called as a potential energy. You know potential energy, energy possessed due to its position. So how much distance is there from the electron to nucleus, that will possess the electric potential or potential energy. So all the metal, in a metal all the atoms are identical. Ella metals onde thara irutte, means ella atoms onde thara irutte. So each atom possess a unique potential difference. Means electrons matte nucleus madhye iranta distance ella atoms allu same irutte. So that is what. So electric potential due to the positive ion cores with respect to the electrons is considered to be constant throughout the metal and hence neglected. Adu constant irodrinda navu neglect ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Now coming to the last one, the attraction and repulsion between the charge carriers are considered to be neglected. Means you know attraction and repulsion between the positive charge carrier and the electron, there will be attraction. Between the electron and electron there should be a repulsion. This is also called as Coulomb force of attraction or Coulomb force of repulsion. In both the cases, attraction agli repulsion agli illi avaru neglect ಮಾಡ್ತಾ ಇದ್ದಾರೆ. How whenever the electron come near to the positive ion core or nucleus, there will be a kind of attraction, or between the electron and the electron there will be a repulsion. Okay, so this also they are neglecting. Both attraction and repulsion between the charge carriers are neglected here. Okay, so these are the 4 assumptions made by the classical theory. Okay, so you need to understand this. ಈ assumptions na ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ quantum theory assumptions na ಅರ್ಥ ಮಾಡ್ಕೊಬಹುದು. See here, these first 2 are important. Third and fourth are both are common. Third point ಮತ್ತೆ fourth point ಏನಿದೆ ಇದು assumptions, ಇದು ಎರಡು ರಿಪೀಟ್ ಆಗುತ್ತೆ ನಮ್ಮ quantum theory. Only these first 2 assumptions will change. Okay, so this is the actual assumptions of the classical theory. Now coming to the sum of the definitions, because you need this definition for the numericals solve ಮಾಡೋದಕ್ಕೆ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. First go for the drift velocity. What is actually drift velocity? It is represented by Vd. It is also defined like this: the average velocity at which free electrons move in a steady state in an applied electric field. So whenever if you apply the electric field, electrons will attain a uniform velocity. So ಒಂದ್ಸರಿ ನೀವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಿದೆ ಅದು ಒಂದು ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿನ ಅಟೈನ್ ಮಾಡುತ್ತೆ. ಆ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿನೇ ನಾವು ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಂತ ಹೇಳಿ. ಸೊ ದಟ್ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಈಸ್ given like this. There is no need of derivation. So where Vd represents the drift velocity, is the charge of the electron, is the applied electric field, tau is the mean collision time. We will discuss this mean collision time afterwards. M is the mass of the electron. So this is the expression for drift velocity. Now coming to the mean free path. Mean free path is defined like this: the average distance traveled by the conduction electrons between 2 successive collisions with lattice points. See, you need to see this diagram. ಈ diagram ನೋಡಿದ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಅದು. See, this individual dot represents the nucleus. ಈ ಡಾಟ್ಸ್ ಏನಿದೆ ಇದೆಲ್ಲ ನ್ಯೂಕ್ಲಿಯಸ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. See this free electron, here we are considering electrons as a gas molecules and they are colliding with the nucleus and changing the direction. See, electron is going and colliding with this first nucleus, then it is changing the direction and it is collided here, then it changes the direction. See here, the distance between two successive collisions, average distance between the two successive collisions is represented by mean free path. Okay, so that mean free path is represented by lambda, that is equal to v into tau. V is the velocity of the electron and tau is the mean collision time. Okay, now coming to the mean collision time, there is a similarity between the mean free path and mean collision time. Mean free path means it is a distance, mean collision time is a time. Okay, it is the average time that elapses between two successive collisions between electron and a lattice point. Okay, it is a time, but this is a distance. Time, actually this expression is defined like this. Velocity is distance by time. So v represent the velocity, tau represent the mean collision time, and lambda represent the distance. V is equal to lambda divided by tau. V means velocity, lambda means distance, tau means time. So velocity equation alli ee expression na ನಾವು ಬರೆದಿವಿ. Okay, so mean collision time means the average time that elapses between the two successive collisions. ಅಂದ್ರೆ ಎರಡು successive collision ಮಧ್ಯೆ ಇರುವಂತ time ಏನಿದೆ ಅದನ್ನು ನಾವು mean collision time. Now you know that electric current is a rate of flow of charges in a conductor. ಇದನ್ನ ನಾವು electric current ಅಂತೀವಿ. So in classical theory we represent the electric current like this: NEA into VD. N represent the electron concentration or number of electrons, E is the charge, A is the area of the conductor, VD is the drift velocity. Now coming to the mobility, mobility means it is the magnitude of the drift velocity acquired by the electrons. Means uniform velocity lo ಹೋಗ್ತಾ ಇರುವಂತ electrons total number means magnitude. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿನ ಅಕ್ವೈರ್ ಮಾಡಿದ್ದಾರೆ, ಆ ಟೋಟಲ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ನ ನಾವು ಮೊಬಿಲಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಕ್ವೈರ್ಡ್ ಬೈ ದ electrons in a unit electric field. Okay, it is called mobility, where mobility is represented by mu is equal to Vd divided by E. Vd is the drift velocity and E is the applied electric field. Okay, or we can represent that expression like this also. Vd expression E tau divided by m alva. Illi electric field get cancelled and you will get only E tau divided by m. Now coming to the very important term, that is electrical conductivity. This is very very important for both the cases, that is classical theory and quantum theory. See, the ability of flow of electrons through the conducting material, it is like a kind of a property. Conductivity is inversely proportional to resistivity. That conductivity is represented by sigma n e square tau divided by m, where n is the electron concentration, e is the charge of the electron, and tau is the mean collision time, and m is the mass of the electron. So you should remember this expression. ಈ expression ನ ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು, ಯಾಕೆಂದ್ರೆ ಫೇಲ್ಯೂರ್ಸ್ ಆಫ್ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ ನಲ್ಲಿ ಇದು ತುಂಬಾ ರೋಲ್ ನ ಪ್ಲೇ ಮಾಡುತ್ತೆ, ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಸಕ್ಸಸ್ ಆಫ್ ಕ್ವಾಂಟಮ್ ಥಿಯರಿ ನಲ್ಲೂ ಇದು ತುಂಬಾ ರೋಲ್ ಪ್ಲೇ ಮಾಡುತ್ತೆ. ಓಕೆ, ಐ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್. ನೆಕ್ಸ್ಟ್ ವಿ ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಫೇಲ್ಯೂರ್ಸ್ ಆಫ್ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.